And over here we have the top 31, how it works with this. I just explained it. And pay attention to this operation. Over here, firstly, you want to read the status register, okay? Because you want to read out the value if the rabbit is 1 or not. That means the register R1 is negative or not. And over here, we use load LDI. But when we go out, that means you want to display, so you want to read the value from A0 and assign it to DDR, so we use STR, that means stop. Means you want to read the value from A0, over here you want to assign the value to A1. So when we go to the implementation for memory map I/O, pay attention to these directions. Firstly, because we use LDI, so you want to read the value from DDR. Is in the memory, so firstly, you want to use expressed in the memory. And secondly, is in the memory, so we have to read it out. And we use the control logic over here to say, yeah, okay, you want to read it out. You know, you want to read it out. And we check, you know, over here we check it. We check it many times. If it is 0 or positive, okay, we check it and we have look over here. But what is negative, we go out. You know, when we go out, you have to assign the value from A0 to the location, that means DDR. At that time, you need to assign the value to DDR. Okay, so you know A0 over here, so we read the value from A0 and we assign it. Of course, we use the memory, okay, firstly, because we use HDI, okay? And over here, secondly, we assign the value to DDR, of course, in the memory too, okay? But over here, we say we use the register as memory location in the memory, so we use two memory, the first, the normal memory, and the second, the register for output devices over here, okay? And we assign the value. Over here we set the value, okay? Over here, you know, over here, okay? You know, over here. And, you know, over here. Over here, firstly. And secondly, we want to assign the value to DDR. Okay? I just mentioned the process for assigning the value from A0 to DDR. You know, when you study, pay attention to the direction. Okay, the first is you want to assign. Okay, so you have to determine the address. Because we use HDI, so we have two memory locations in the memory. The first, okay, over here. You understand? Over here. And the second, you have to use the address. And the data recited to DDR. And generally, we have the keyboard equal to 10. Over here, basic input routine, and over here basic output routine. Is you point 1, point 2 to say is you want to input and you want to output. Okay? Over here. Do you remember? And pay attention to declaring this location for KDSR, KBDR, DSR, and DDR addresses and ladders. And the last one, when we go to interrupt ribbon IO, you should understand the mechanism. When we go to the chapter about stack, you study this again. But over here, you should understand the general mechanism for interrupt ribbon IO. For the HOD device, you know, the input-output device can force currently executing program to stop, and it has the processor satisfies the device needs, and it can resume the stop program as if nothing happened. But over here, why do we need to study? Because you know, when we do the poly mechanism, maybe we take a long time. And when we use data-driven I/O, maybe it's shorter. So that's a problem. Why in future we use the mechanism interrupt. If you want to work with, or if you want to program to work input output devices. And when we study interrupt, so maybe you need to understand the way for input-output device to signal the CPU that an interactive event has occurred. And the way for the CPU to test if the interrupt signal is set and if its priority is higher than the current program. So therefore, because now let's imagine, you know, the CPU is running a program, and if you want it to interrupt the current program, so we have to say to CPU that now CPU, you want to stop your current running, and we want you to run the program we want. So how can you do it? After that time, the CPU have to say, now if you want to stop me, I have to check if you have the higher priority, so that time I can stop and I can serve your program. Okay, so at that time we need this mechanism. That means firstly you have to signal the CPU to say you want the CPU to stop. But they should say, okay, you can or not. So I have to check it. Okay, so over here, if you have the high priority, so I said yes. Okay, so firstly, how can we generate the signal? Okay, so over here, pay attention. Generally, for the real CPU, we can generate the interrupt signal to the CPU via hardware and via the software. And over here, the software says interrupt enable bit in device register. Especially when we study LC3, we use the software to set the interrupt enable bit in status register over here. For example, in KBSR, we have the bit 14. Over here, we have bit 14. So that is interrupt enable bit. Do you remember bit 15? So that is the relay bit. Okay, this is the 14. Okay, this is bit 14. Okay, until the end to generate the interrupt signal to processors over here. And because I just mentioned the priority, so I say when you want the CPU to stop the current program, so it has to change the priority. Okay, at that time when the LC3 you have each level of priority from priority level 0 to priority level 7, and priority level 0 is lower than priority level 1, and priority level 7 is highest. And priority encoder selects highest priority device compares to current processor priority level and generates interrupt signal if appropriate. And over here, the process for checking for interrupt signal. For instance, do you remember instruction processing? Because you remember, so we have 6 phases from fetching to storing. Okay, and you know, if you run a program, you have many instructions. And when you run each instruction, so you have 6 phases for each instruction. Okay, from fetching, the code to storing the data. And when you study interrupt over here, before going to the new phase of fetching, so the CPU look at signal, okay, interrupt signals over here, okay, it yes, the CPU say, okay, now I check it yes, so the CPU go to ISR, that means interrupt subroutine, to do the program, okay, and after it go to the end, that means the program interrupt subroutine, okay, and then it go to the next function of the program, okay. And totally you have the picture, that means the full implementation of LC3 memory map I/O. Okay, you study input devices, keyboard, output devices for screen. Okay, address control logic with memory. Okay, over here, totally. Okay, you study. This is the end of the program. Okay, that means because you study memory map I/O, over here with the chapter you study the program for interfacing with input output devices, in fact memory map I/O. And when you go to the chapter about stack, you study more about interrupt. Over here only the program for input output devices, and you have some exercises for your homework. And you have some questions for reviewing. And you have the homework at the end of the chapter in your textbook. I will upload it to Weekly Learning for you.